Welcome, ladies and gentlemen, to Distance Learning. We are going to be talking about rational exponents today. And rational exponents are going to be exponents that are going to show up like fractions. So we've been able to deal with stuff like 3 squared. That means 3 times 3, which we know is 9. And so today we're going to deal with things like 25 to the 1/2. And what we're going to learn is that stands for a square root of 25, which we know to be an answer of 5. Now, before we get into this too much, we've got to talk a little bit more about roots. So, let's talk about the square root. The square root of 25 means find one number that multiplies by itself twice to give 25, and we know the answer is 5. And the way that we do that is 5 times 5 equals 25. And notice that there was 2 of them. Now, we don't always have to write this 2. Often, we just write it without the 2, and it stands for the square root. Okay? But there are other roots as well. There's what we call the cubed root. So the cubed root of a number, like the cubed root of 8, would be find one number multiplied by itself 3 times, so that there's 3 of them in total. That gives 8. Well, that's 2 times 2 times 2. So the cubed root of 8, the number multiplied by itself, so there's 3 of them, to give 8 is 2. That's the fourth root. A number that multiplies by itself, so there's 4 of them, to give 81. That would be 3. And we can have the fifth root. I think this is the fifth root of 2. Let's find out. Using my calculator, I can do 2 times 2 times 2 times 2 times 2. Nope. The fifth root, the fifth root of 32 is 2. And the sixth root of 64 is going to be 2. So 2 times 2 times 2 times 2 times 2, so there's 5 of them is 32. And 2 times 2 times 2 times 2 times 2, so that there's 6 of them, is 64. Let's just make sure. 2 to the 6 is 64. Okay, now, following what we've said earlier today, is that each one of these can be represented as a rational exponent. These are being represented as radicals. Okay, those are radicals, and a radical is composed of a radical sign and a part in here which we call a radicand, and a part out here that we call the index number. So the index number is 3, the radicand is 8, that's the radical sign, and the answer is 2. That's how that works. And as we're going to learn today, whenever we have a radical of nth root, let's just give it a base of a. So we have a base of a with an nth root. That can always be rewritten as a fractional exponent with a 1 on the numerator and the n goes on the denominator. And that's just the way it is. Okay, so that's new and we sort of got to learn that. The next thing that we're going to need later on today, and I'm just going to show it to you now, is that if I have a number like 3 over 5, I could rewrite that number as 3 times 1/5. Now let's just see why that works. The 3 is 3 over 1, top times top, bottom times bottom, is 3 over 5. So a number like 4 over 7 could be rewritten like 4 and 1 over 7. And since the order of multiplication doesn't matter, this could also be written as 1/7 times 4. 4 over 1, top times top, bottom times bottom. So we're going to use this later on today as well. Okay, so let's get on to the actual lesson. Radical expressions. An example of a radical expression is a square root of 25. That has an answer. That has an answer of 5. You evaluate it by finding a number that when multiplied by itself gives 25. So 5 times 5 is 25. And what we have to remember here is that there's an invisible index number here of 2. which represents for the 5 times 5, 2 5s. This one has an index of 3. So we're looking for a number that multiplies by itself, so there's 3 of them. And that corresponds to the 3 2's multiplying to give 8. So this is the cubed root. This concept can be extended to 4th roots, 5th roots, and so on. And then we call the general one the nth root. So something like this is called the nth root. Evaluate. If possible, do so by hand and with a calculator. So I'll do them by hand with you, and you figure out how to use your calculator to get the right answers, because every calculator is going to be different. So I'm looking for a number that'll multiply by itself. So there's 3 of them in total to give 64. So I don't know what that number is. I'm going to try. Maybe it's 2 times 2 times 2. 8, not big enough. What about 3? 3 times 3 times 3. 27, not big enough. What about 5? 5 times 5 times 5. 125, too big. What about 4? 4 times 4 times 4. 64. It works. So the answer is 4. Now, how would I have done it on my calculator? Well, that's a little bit trickier. I don't have a button that looks like this. Many of your calculators will, and you should find it. The nth root button. Okay, I don't have a button that has that. I have a button that's going to have this. Okay, and remember what I told you, that whenever you have an nth root, it can be rewritten as a fractional exponent. So these actually mean the same thing as long as you know a little bit of math. So for me to do this on my calculator, I'm going to put in 64. I'm going to hit this button, and then I'm going to put in 4. And then I'm going to put in 3, and because that's going to be the nth number. So when I have 64 to the 3, it's going to be 64 to the 1/3. So for me to do this on my calculator, let's see. There's that button, x to the 1 over y in my case. It doesn't matter what these values are, if they're x, y's, a, b's, whatever they are. So I'm going to do 64, hit that button, shift, and then I'm going to hit 3, and I get the answer of 4. And like I said, it's going to take you some time to figure out how to do this on your calculator. Let me zoom in on here a little bit, just show you what the button really looked like on mine. Let's see how, there we go. And here it is here, x to the 1 over y. Okay? And I had to hit shift to get it because it's up here in this different color. All right, so let's do the next one. I want to do the answer of what number multiplies by itself, so there's 4 of them, to give 625. Well, I'm going to guess at this point. I'm going to suggest maybe it's 7. 7 times 7 times 7 times 7, 2,401. Way too big. I'm going to think maybe it's 6. 6 times 6 times 6 times 6. Nope, way too big. What about 5? 5 times 5 times 5 times 5. It worked. So the answer here is 5. So 4 5s all multiplied together gives me 625. Using my calculator, I would do 625. Second function, 1 over y button, 4 equals 5. This one. Now, I'm going to tell you that this can't be done. The reason why it can't be done is because I'm looking for a number that multiplies by itself, so there's 4 of them, to give me a negative. And there's no way that'll work. Think about it. If I have 4 negative numbers, it's going to work out to give me a positive. And if I have 4 positive numbers, it's going to work out to give me a positive. And since this number has to be the same, it either has to be negative or positive. Either way, this is not possible because of the sign. Now, the 16 is easy. It's 2. 2 times 2 times 2 times 2 is 16. But the negative gives you a hard time here. And if I tried to do this on my calculator, now you got to be careful. The bottom is going to be negative 2, shift 1 over y to the 4. And my calculator says error. You got to be careful how you put that in, because if you put it in incorrectly, then it's just going to give you the 4th root of 16. and you might incorrectly think that the answer is 2. But this one can't be done because of the sign. So that brings us to here, roots and rational expressions. What I've already told you is that when we have the nth root of a base, it's equal to 1 over n. Now notice that the numerator is 1 and the base is n. So roots of numbers may also be represented as rational exponents. So in this form, we call that a radical. It's radical form. In this form, we call this exponential form. Okay, we've got to keep that straight. We're going to have both different forms that we're going to work with, and we're going to convert back and forth. So this one could be changed into 4 to the 1/2. Either way, it's still equal to 2. And this one can be changed into 32 to the 1/5. And again, it's going to be 2, because 2 times 2 times 2 times 2 times 2, 5 of them, gives you 32. Evaluate where possible. Verify your results with a calculator. So this is asking for 100 to the 1/2. Well, we know that that equals the square root of 100, and 10 times 10 is 100. This will be the cubed root of 1,000. And we should know that that's 10 times 10 times 10, which is 10. This is the 5th root of 32, which is 2. And this is the 4th root of decimal 0001, which is going to be 0.1. Now that one you might want to check. So I'm going to check with a calculator by doing 0.1 to the exponent 4 equals. Now see that? That is in scientific notation. If your calculator does that, then you need to change your mode. I'm going to go on my calculator. It says hit mode and then hit normal. So mode and then normal is 9, and it shows up with our standard decimal form. So 0.1 to the exponent 4 is going to be 0.0001, which is what we had here. Okay, I'm going to stop there and then we'll do the second page.